Hello everybody, welcome to another Welding Wednesday here at Sunstone and Orion Welders. Thanks for joining us. Today we're talking about something that really is something that's just so awesome, and it sets our welders apart from everyone else. Actually sets our welder, the 200i2, apart from everyone else. That's the machine I have behind me right now. We're talking about waveforms. We're talking about waveforms today. All of our Orion welding systems, pulse arc welding systems, have what's called the classic waveform on it. But the 200i2, which is our top of the line pulse arc welder, which is here behind me, this machine has two additional waveforms, and that's what we're going to talk about today, because these two additional waveforms are what set this machine and our company apart from everyone else when it comes to pulse arc welding. The waveforms, they're made to help you save time and be able to do projects better. But one thing to remember is that you have to kind of experiment with them to be able to learn about them. Today we're going to teach you about just some of the basic knowledge about these waveforms and give you an idea of where you can start, and then you can experiment with the waveforms from there. So the waveforms are really going to give a competitive edge to you and your business, okay? If you know how to use them properly, it's going to allow you to, like I said, do work quicker and better than the guy down the street, right? So people are going to come to you, or if you're a repair business, or people are going to come to you if you're a mold and die business, because you're able to do these things quicker, more efficiently, and with better results. So remember that. 200i2 offers a whole nother level of welding that our other systems don't, because of these waveforms. Now, I have to use my cheat sheet today because there's a lot of things we're going to go over, and I want to make sure I say and explain the waveforms correctly. Okay, so I have my cheat sheet here. Remember, with what we're telling you today, there really are no perfect settings, okay? You can start and then kind of adjust, and if you find a setting that you really like, the cool thing about our system is that you can save it. You can save the setting, and then that way you have it for future reference, and you can look back on that. But just remember, you can always adjust, you can move your welding time or length up a little higher, or adjust your power, and you'll see what we're talking about here in a minute. So, like I said, all of our welders, you have what's called the classic pulse arc welding waveform. We're going to put a screen up right now that shows that. And here it is right here. Okay, so this is the classic waveform. As you can see, the first couple lines in the bottom left corner, that's your ignition, that's igniting the weld. But that initial straight line up, or the straight line up that's going to the highest point, that's your initial power, right? That's the peak power. When you light up your piece, that's all of the brunt of your energy, right? And then as you can see, there's a sloping curve down, and that kind of tapers off. Now, this waveform, it's great for basically any type of welding. That's why it's on all the machines. It provides a smooth, clean weld. And as you can see here, we bullet pointed some points about this waveform. So it's used on all of our systems. It's the most versatile welding waveform, which means basically any application you're going to be safe using the classic waveform. You have a high peak current, which is that straight up line I told you about, which provides an aggressive melt. Okay, so that's the reason why you're able to melt both pieces and fuse them together. And then you have a quick downslope, and the reason why the classic is good with that quick downslope is it keeps the heat affected area very low. So if you're working near prongs, or you're working near something that you don't want the piece to have a lot of heat around whatever you're welding, maybe you can melt some plastic that's near the metal, or ceramic, or anything. So the classic waveform, it'll give you that quick initial power for melting, and then a quick downslope that provides a low heat affected area. So that's really important to remember, because with the other two waveforms we're going to talk about, they usually have a lot more heat than that classic waveform. It's going to heat your piece up. It's going to heat the area up a lot more. So that's important to remember. Let's see here. So yeah, and then that aggressive bullet point, it does an aggressive, strong weld like I mentioned, but it doesn't do a lot of heat buildup. And then, what does that last one say? Thing?
Only preset lengths.
Only preset lengths. When you're using the classic waveform, you are limited to the amount of length or time that goes into the weld. So now we're moving to the triangle waveform. As I was mentioning, with classic waveform, you're limited to what you can set your time to, whereas on the triangle waveform and the square waveform, you can adjust your power and your time independently. You can go as high or low as you want on either. You're not set in specific boundaries. So now we'll talk about the triangle waveform. We have another screen to show you. Okay, so with triangle, it looks very similar to classic, but you see that instead of kind of a sloped down, it's a straight, just a quick cutoff instead of a sloped. So again, this is a feature. Triangle is only available on the Orion 200i2 welder. You get a smoother weld and deeper weld penetration compared to triangle when using this waveform. You have a smaller weld diameter, but with deeper weld penetration. You can set the settings to where you can really hit it with the right amount of power to have a smaller weld diameter and deeper weld penetration than you could with the classic. You get even and gentle cooling to avoid heat cracking. So you're getting a deeper penetration, and this is really important to have that equal or even and gentle cooling, and that is to make you have a stronger weld so that there's no chance of cracking. What does that last one say?
Adds more heat.
Adds more heat. So, like I mentioned before, you're adding a lot more heat with a triangle waveform because it's not sloping down. So with the triangle, you're getting deeper penetration and a smoother weld, but you are running the risk of heating the workpiece up a little bit more. So be careful with this one when welding, again, near things you don't want to melt, or precious stones, or wire, or anything really. But it does provide a really clean, smooth weld. You'll talk to anyone and everyone's going to have a different opinion. I work a lot with triangle mode. I just think that the welds look very pretty. There's less cleanup. But I do change if I'm going to be welding, a prong or something precious next to a stone or whatever. And I move back to that classic mode. You can still use triangle mode welding next to prongs. Just make sure you have your power and your time low. As we've always mentioned, start with your settings low and then slowly work them up. Now in the classic mode, you would usually just change your power and not even have to worry about the time because that changes automatically. However, in the triangle and square waveforms, you have to move them together. You have to, if you're going to adjust the power, then you adjust time and vice versa. You don't always have to, but generally speaking. So now we'll talk about the square waveform. Okay, so some of the benefits or some of the features and benefits of the square waveform. Again, only available on the 200i2. The current and voltage have almost no rise time. So what that means on all of our setting, whether classic or triangle, you really have almost no rise time, right? that peak current, it happens very quickly. But as you can see in this image here of the square waveform, once you hit that peak current or power setting, you can see on the square waveform it holds that all the way until the end of the weld. So if you have that happening for 10 milliseconds or 100 milliseconds, it's going to hold that until the end and then cut off. So this is a waveform that is useful for metal pushing, and we'll show you an example of that. You can add thick pieces of metal if you're doing mold and die repair, or if you just have a big area of hole or porosity that you need to fill, you can fill that in really easily with this waveform. With the right settings, it also it will provide an even deeper weld penetration. So all things equal to the classic or triangle, keeping those power settings equivalent, when you're using square mode, you'll get a deeper penetration, which is nice, depending on your application. And we'll show an example of welding a ring together with just one weld. It'll basically cover the whole area of the ring, fusing it together. It's pretty cool. Square waveform adds the most amount of heat to a workpiece. So if you can't heat the piece up a lot, if you need a very low heat affected area, do not use triangle. Again, you can use it, don't use square. I said triangle, excuse me. If you need a low heat affected area, do not use square. But if you're okay with the part heating up, there's no precious stones or anything that's going to be damaged, then it's okay to use that square waveform. You can also bring the square wave power down very low, and so if you did want to do some smaller pieces, I've heard that it works really well with silver. So something you can experiment with, and that's the key thing we want to make sure everybody is aware of. We're learning the reasons why these waveforms do what they do, but experimentation is always important. When we did the one weld on a ring and realized that it closed the whole ring, we were experimenting and we found that, and that's how we found that setting, and it's really cool. So some of the key things to remember, I'm going to talk about two things real quick to help you understand waveforms. All right, we talked about the features and benefits of the different waveforms. Now I just want you to kind of imagine something with me right now, okay? So one way that we help explain how these waveforms work is likening it to like a pond, right? So you have a pond, it's completely flat, there's no ripples in it, you can see your reflection, it's so still, and then you throw a rock into it, right? When you throw the rock into the pond, there's all those waves that start to go. Now with the different waveforms, if like with the classic one, you throw that rock in, and those puddles slowly taper out, right? With classic waveform, you're typically using the maximum amount of time that's allowed with the power setting you're using. And what that does is it allows that to smooth out. Now if we chop that time in half or even more, 3/4, what would happen is you would have to imagine the pond freezing, okay? You threw the rock in and then you froze the pond. And then you would see all those ripples and they'd be stuck like that. And that's kind of what's happening with the different waveforms, okay? Same goes for triangle and square, right? You throw that rock in, or you hit whatever you're welding with that power, and it's melting the metal, and it's kind of puddling up. If you don't have a long enough time, it's going to puddle up and you're going to see waves. But if you give the right amount of time to your weld, you're allowing that to smooth out. You're allowing that melting puddle to basically smooth out. And as we talked about with triangle and square waveforms, you're able to set the right settings to really get a smooth weld that's pretty cool. Did I explain that well enough, Thane? Is there anything you want to add to that?
Just as you're working with square and triangle mode specifically, the length is just as important as the power. And so the analogy that Scott's using there is explaining specifically that length and why it's equally as important.
Yep. So the length, like exactly what Thane said. Adjust the length to always get a smooth weld, and that'll avoid pitting and holes. The second thing I wanted to explain, and now we're going to go to the screen. So Thane, can you give us the view on the screen? Okay. So let's see here. I can adjust this. It's all right. Okay, as you see here, here's our waveform. This is the square waveform. So the next thing I want to talk about is using high power. I'm going to go to triangle mode to demonstrate this one. Okay, so let's bring our power down and our time down, okay? Okay, so high power, so if we're moving the power up, and you can see that as I move the power up, it goes up right here, right? So high power and short length, what that does is that creates high penetration. You'll get the deepest penetration when you're welding with high power, short length. But you have to remember there's less smoothing when you do this. So you're going to have a puddle or you're going to have a hole. So there's things you can do. If you're wanting this result, you can flatten the electrode, and that'll help eliminate some of the hole and pitting and whatnot. But just remember, if you're having high power and short length, you're getting deeper penetration, but less smoothing. Okay, now if we do the opposite, we bring our power down, and we lengthen the amount of time the weld is happening. What's going to happen is the opposite, right? You're going to have low penetration, but it's going to be more smoothing. Now this is a really sweet thing you can do if you want to, you're adding metal, you've just filled out some porosity to add metal to an area, or you've just resized a ring, you have a lot of metal there, and you want to smooth that metal out before you, bust out the sander and the buffer and everything. You can actually use the welder and weld around that area to smooth the metal out. It's really cool, and you can do the same thing in the square mode, right? You can keep your power a little bit lower, but really extend the length of time, and what it's going to do is it's going to be less penetration, but it's going to do more smoothing. If you've ever welded with a laser, that's very similar, right? You can make the light beam wider and use less power to kind of smooth an area out. Well, that's what this on the pulse arc welder offers. It's very different. Laser welding and pulse arc are different, but that's kind of what you can relate it to. So that's something to know. So now the thing to remember then is you need to find a balance between those two. All right? So do you want a lot of penetration? Shorten the time. Do you want less penetration? Extend the time. But then you have to remember also, if I'm using more power, if I'm adding time, I'm adding more time that heat is touching the piece, so it's going to heat the piece up. So just remember, you have to balance between those 2 points that I just talked about. Okay, high power, short length, and then versus low power, long length, and then you find that happy medium where you're able to do the application that you're doing with the perfect setting. And always remember, a good place to start is always in the middle when you're doing that, right? So I'm going to go back to my triangle mode here. Something that I like to, when I'm teaching people how to use the waveforms, before experimenting with high power, low time, or low time, high power, I always say, you know what, start low, start with your power low, and start with your time low as well. And you can see here you have a dark green when you're low time and a dark green when you're low power. And as you move those up, the colors change, right? So I'm starting to get into yellow, and then red, as I go around, right? So as you're experimenting, as you're first starting out using a square or a triangle waveform, first start with just keeping the colors the same, all right? And then from there, do these things that we've taught you, right? Raise the power, lower the time. Raise the time, lower the power. And you'll see the differences, but the key things to remember: higher power, shorter length is going to give you more penetration. Lower power, longer length is going to be less penetration, more smoothing. So let that be your guide, okay? And that's the key thing to remember when working with triangle and square waveforms, okay? So remember those two facts, and then adjust your power settings from there. Sorry, I turned away from the camera. So on my paper here, the next thing we're going to talk about is, okay, now if you're watching this video, you might be thinking, oh, I have the 100C, or I have a 150S, or I have that other machine that's a grayish color and doesn't say Orion on it. And you know what? I really want these waveforms. I want to be able to have this competitive advantage. I want to be able to experiment more. I want to be able to have smoother welds. Whatever it is, there's a couple things you can do, okay? If you want a 200i2, sell your welder and give us a call, and we'll hook you up with a 200i2. Second, we have trade-in options, all right? If you want to trade in your old welder and upgrade to a 200i2, give us a call. Let's talk. Let's see what we can do for you, all right? But we do have that as an option. And then lastly, yeah, just purchase a second unit, you know? That's kind of like dirt bikes or skis or whatever you love, you know? The more the merrier, right? Maybe not always, but that's an option, okay? We just want you to know you can do what's best for you. If you love what you're using and it's working great, continue using it. But there are options if you want to upgrade to the 200i2. If you don't have a welder and you're trying to decide what welder to get, think about an i2. Think about these things we've talked about. If this is kind of the tipping point of to getting an i2 or a laser or that other machine that's gray and doesn't say Orion on it. You know, these are things to think about. So we want to talk about waveforms because we don't want you to feel like it's an intimidating thing. We want you to feel like it's an advantage, because it is an advantage. And it's pretty simple. Once you watch this video and you learn about them and then you start experimenting, you're going to see that you'll probably spend 99% of your time in a square or a triangle waveform just because of how awesome these waveforms are. So let's get to welding. I'm going to start doing some welding. I hope you guys are thinking of questions to ask. Maybe you can send some stuff in and we can get some questions answered for you, as this is a place we find that a lot of good questions come in. So first, I'm going to show you the welding a ring with just one weld. And the reason we're able to do this is because we can adjust our time and power independently, and we're going to see like what we just talked about, right? High power, long time, it's going to give us penetration and a lot of heat. So this is something that we're going to do the one weld on our ring. And this is something you should remember about these settings and this application. It's okay that my heat affected zone is very large, okay? I would not want to do this if it was close to something that I didn't want to get hot. So remember that. I'm going to do a weld right now. Focus right there. Okay, so what I'm going to do here, hold on, let me put a weld on this to hold it together first. And where are my settings? That should be good enough just to hold us. Oh, a little bit more power. Underestimated my piece size here. Okay, that was good enough just to hold us together. Okay, so I'm going to cut this, as you can see. And then what I'm going to do, I'm going to go to the square waveform. I'm going to add sustained agitation. We're in the standard plus ignition. And I've set my time to 33 milliseconds. And I've set my power to about 3.5 kilowatts. So, as we've discussed, this is a lot of time, so it's going to allow for smoothing, but it's also quite a bit of energy going into it, so it's going to do a good penetration and do a full weld on the ring. Now adding that agitation, as we talked about in other episodes, it's going to add extra energy, so it's really going to hit it hard. So what I want to do is actually, it's going to heat up a lot, and I forgot my gloves, so I'm just going to hold it with a towel, which should be fine. Okay, can we see that all right, Thane?
Good.
Okay, here we go. One weld. Now, right there, as you can see, all the way around the ring, completely welded, and that heat, it gave a lot of heat, and that's why I had to hold it with a towel. But I don't have anything else around this ring that I'm worried about heat. Okay, let me wipe off some of the weld soot, just so you can see that it's nice and clean. So there you have it. Again, let's cut to the screen thing so they can see the settings that I used. Okay, so as you can see, square waveform, standard plus ignition. I added sustained agitation, my milliseconds, the length of my weld, 33.37, and my power, 3.56 kilowatts, okay? Again, single mode, touch detect, everything you know about welding. But this is the setting we use to be able to do one weld and cover a full ring. Next, so you're probably wondering how thick this ring is. Thing, do you want to go grab real quick some calipers? They're on Jason's desk. Oh, is it 1.5? There you go. This ring is 1.5 millimeters thick, and that was the setting we used. So if you had something thicker, adjust that power up a little bit, adjust the time up a little bit, and you'll see a similar result. If you have something smaller, again, bring those down. But that's the ratio that I used in this setting, right? I used 33, 34 milliseconds of time and 3.5 kilowatts of power, okay? So again, if I'm going to have a smaller ring, I'm going to bring those down. Next, we're going to do a weld of moving metal on a thicker piece. Okay, so actually, have we cut, let's see, this camera, so let's leave that camera on real fast. So, just so you can see what I'm welding here, this is a thick piece of stainless steel. We're going to add a thick piece of wire to it and then kind of move that wire around so you can see what it looks like.
That's just mild.
What is it?
Mild steel.
Oh, sorry, mild steel. Mild steel. I was going to say potato, potato, but no, they're definitely not the same. So, okay. If you're doing stuff like this, you can get little thimble things you can put on your finger for your copper grounding. What I'm going to do is I just have to kind of hold it here with my finger, just so you know if you're doing things like this. There's different ways you can clip a thick piece like this. But as you can see here, I have my wire. You probably can't tell really in the video, but that's a pretty thick piece of wire. I'm thinking at least maybe 15, 16 gauge wire. And with this one, I'm going to go to the triangle mode. And I'm going to do standard plus. I'm not going to do any agitation, so none there. And I've taken my power up to 8 kilowatts. And my time is at 17 milliseconds. And here we go. Okay. Now, that's just so you can see on the triangle. Now I'm going to take it to square. And with square, I'm going to take the power up to about 5.5. And my time is at about 20. Well, got a bad angle there, but we are okay. Oh, hold on, I gotta adjust my grounding clip. There we go. Sorry if I'm blocking the camera.
You're good.
Okay. Alright, so we've added a bunch of metal here. Now, I'm going to use the welder, and again I'm in square mode. I've moved my time up to about 28. I'm at 5.5, and we're just going to smooth this out. Now the trick, so I'm trying to find the best angle on this camera. So here's my mountain, right? What I do is I actually I'm touching the mound of metal and the block of steel at the same time. In that point where the metal then hits the flat part of the steel, what it does is it pulls the metal. And with this square waveform, it's sweet because it just smooths it out and it flattens it out so well and so quickly. And again, if you think about the pond analogy, we're using so much time that it's allowing that metal to melt and smooth out. And another cool thing, just to brag about this welder, the electrode is in awful condition right now. This welder has something on it that we'll have to talk about in another episode, but it's called adaptive weld ignition. Okay, the welder really gets a sense of where you are in relation to the metal, so it knows when to fire. So even when you have an electrode that isn't in the best condition, you still get really good welds. And you know, it helps eliminate metal sticking to the electrode. So I know this is an episode on waveforms, but we just got to brag about that feature as well too, because it just makes it one complete system. Let me clean up this electrode real fast. Again, really easy to do. Oh, there it is. Woo. Alright. If you guys are ever out there and you do a live webinar or anything like that, or you go to a trade show, or you have to do live demonstrations, nothing ever goes like it did when you practiced. I just gotta tell you that. It's really funny. Not that anything went wrong in this video, everything's perfect, but, you know, just thought I'd throw that out there. So there you go. Just beautiful smooth welds, okay? So, again, pushing metal is something that you're able to do with thicker welds, thicker metal. Last thing I'm going to do is just show a difference between the three waveforms on this piece of metal, a flat piece of metal that I have. Hey Thane, should I do that on this side, or does it matter? And just show... Okay.
Just a comparison.
Alright, so here's my sheet of metal. As you can see, it's just a flat sheet. And what I'm going to do is I'm going to try to keep all things equal and show you the difference between these different, just kind of how the weld will look different depending where your power is at. So, I'm going to go to 4 kilowatts of power in the square waveform. And I'm going to make my time be at 25, and this is what our weld is going to look like. Okay. Now, going to hit the triangle button, and what it has happened here is it moved my power up to about 8.9, and it dropped my time a little bit to 17. So what that equals is basically what the same amount of overall power was from the square waveform. So I'm just going to do another one right here. Okay. Now, through my microscope, I can probably see a lot better than what you're seeing. But right here, I can tell it's very much on the surface with that square, because we had a long time and I wouldn't say the highest power, but doing all things equal with the triangle, because I'm getting that peak power and then the cool down instead of holding it, it looks like it's able to get a little bit more penetration on that. So there's that, and then we're going to go...
Backside.
What's that? Like that?
Backside of the card.
The backside? Oh, that's right. So this is going through the card, right? So the one right here on the right, that's the square one, and this is the triangle one. So you can see... here, let me do another so that it's you don't have a black line in the way. So we need to go down. So we'll do a square one this is a triangle again. And then we're gonna go square. Okay. So you can see you get a little bit more. Oh, I'm trying to find the right angle so you guys can see that. Sorry about that. So pretty similar. You get a little bit more penetration on the triangle side, but pretty similar. Then if we go to classic, the similar setting here would look like this. So as you can see, it's a bit smaller. Oops, I'll turn that off. It's a bit smaller, and it's right on the line. I'm gonna have to do another one. Hold on. You can barely see it, but right there, there's a little, just a little bit of penetration. So you can see with your square and triangle waveforms, you're getting much more penetration, as we've talked about. I mean, that's what is happening with these. And then adjusting that time allows for a really smooth cool down. Yeah, you can't even see, oh, right there, kind of. You can barely see where that classic waveform came through. So you're getting deeper penetration with your square and triangle waveform. And I think that's going to be where we leave off. In conclusion, you know, we've already mentioned, just remember, this is simple. Don't let it be something that's difficult. Remember the things we talked about. Go to our training webpage, okay, and look for this webinar. We're going to put up images and things to remember so that when you are working with the different waveforms, you're able to feel confident and you're able to continue to experiment and try new things and learn new things and figure things out that no one knows because you're the master of your machine. You're the master of your trade. And that's what's cool about these waveforms. They really open the doors to so many options of things you can do. So many different settings. It's limitless almost, it feels like. So it's really cool that you're able to do that with this simple system. finding the perfect setting for what you're doing in that moment is awesome. It'll eliminate cleanup, it'll save you time, and you're going to be astounded at how quickly you're able to do things and how clean they will be. It'll be less cleanup work for you when you're finishing your piece, whatever it may be, and that'll be really cool. Again, everyone out there, the reason you probably have a welder is because this is your livelihood, this is your business. Save time, make more money, all right? Those correlate, right? When you're able to save time and do the same amount of work, it allows you to bring more work in, therefore help you to make more money. And that's what we want. We want you to be able to have a system that allows you to do that. Save time, be more efficient, be more effective, and be able to do more work. So that's something that's really important, you know. We want you to be successful in your business, and we hope that our tool is able to allow that to happen for you. And I believe that's it, you know. And in conclusion, the perfect setting, it's going to vary. It's going to vary on person, it's going to vary on your application, but you now have the knowledge of how to find the perfect setting, okay? Experiment, try new things. You may think you found the perfect setting, and then you polish it, and there's a little bit of porosity. So you change that setting, you know, bring the power down or bring the time down a little bit. Do the same thing, weld. It's going to be clean, it's going to be awesome, and that's how you find the perfect setting. So, thank you for joining us. Let me see if there's any questions out there. Anything?
No questions, just next week will be on Monday.
Oh yes, that's right. Next week, the webinar will be on Monday. We will be traveling to different trade shows throughout the week, so we won't be here. So Monday, we're going to do that because we will not be here on Wednesday. So we will see you then. Thank you for joining. Call or email us if you have any questions, and keep an eye out in the next day or two for the training. If you go to sunstonewelders.com, there's a training tab up top. Click on that and you'll see inside there a page specific to waveforms and the things you need to remember. Thank you. We love you. We'll see you next week.